Okay, so this video is to help you with 7.2 independent practice 2. So this is going to be on zero exponents and negative exponents. And I know negative exponents were a cause of concern in our classroom, stressed a lot of people out. So hopefully this video will clear up some things that you were struggling with when we did negative exponents the first time. And I hope you guys are doing okay. Just hang in there. And of course, if you need any help at all, you can always ask. All right, so let's get started. So zero exponent. Any number raised to the zero exponent equals 1, okay? So that's just a rule to remember that anytime you have a zero exponent, the number is going to equal 1. And just to show you where this comes from, this actually comes from the division of monomials where we subtract the exponents that we talked about last video. So if you didn't watch that video, 7.2 independent practice part 1, watch that first because we're using that property to explain the zero exponent. So to show you what I'm talking about, we've been using 2 as an example, right? So 2 to the 2 divided by 2 to the 2 is 1, right? Because any number divided by itself is 1. So if we applied the division rule, we would get 2 to the 2 minus 2 is 2 to the 0, which is 1, okay? So that's where that comes from, is we're basically just dividing the same number by itself to get 1. So just remember that anytime there's an exponent of 0 to a number or to a set of numbers in parentheses, the answer is going to be 1. So take this example. You might look at it and think like, oh my gosh, Miss Hanfer, why would you do this to us? This is awful. Look at it. It's so hard. But is it? Because what is going on here? There's an exponent of 0 outside of the parentheses. So what that means is applying our power of a power property. If we multiplied 0 by all of the exponents inside, every single value inside the parentheses would also have an exponent of 0, right? Because any number times 0 is 0. So everything in here is going to reduce down to 1, okay? So I use this like very dramatic, extreme example so that you would remember it. So anytime you see 0, just make sure you reduce that to 1. So the next rule that we're going to be talking about is with negative exponents. So any number raised to a negative exponent flips the position in the fraction. So if it's a numerator with a negative exponent, that's going to become a denominator. And if it's a denominator with a negative exponent, it's going to become a numerator. But it's going to keep the same value. So like if you put absolute value bars on the exponent, that is going to carry with it if you're flipping it from top to bottom, okay? So I'll show you kind of where this comes from as well. It's again using that monomial division property, okay? So when we have, let's say 2 to the 2 on top, but 2 to the 4 on bottom, then we would actually end up, if we wrote this all out, if we expanded it, 2 times 2 on top, 2 times 2 times 2 times 2 on bottom, right? 4 2's on bottom. And if we want to cancel out some of those 2's by reducing them to 1, we cancel out 2 sets of 2's. And remember, you would always have kind of an invisible 1 being multiplied. So when our final answer would end up being 1 to the, or divided by 2 to the 2, right? Because we have 2 2's left on bottom. So if we reduce that down, it'd be 2 to the 2 or 4, but we're using exponents to kind of demonstrate what we're talking about here. So if we wanted to just go ahead and use the quotient of powers rule, where we say we can subtract exponents, right from the beginning, we would have 2 to the 2 minus 4. And what is 2 minus 4? Negative 2. Okay, so here we have 2 to the negative 2. But we know that this equals 1 to the 2, or 1 over 2 to the 2. So it's demonstrating that negative exponents just mean that that value is actually on bottom. So we're keeping the magnitude of 2, but to get rid of that negative, we have to flip it, because right now, this is over 1, because any number divided by 1 is itself. So you can say that this is a fraction over 1, so then when we flipped it, the 1 would be on top, and 2 to the 2 would be on bottom, okay? And so just be aware that you cannot simplify things with a or you have to simplify things with a negative exponent. Negative exponents are not in their most simplified form. So whenever you're given a negative exponent, you can't have an answer with a negative exponent if you're being told to simplify. You're going to have to move it and get rid of it. So now we can do some examples to get you acquainted with what you might be asked to do in simplifying a problem, okay? So there's actually 2 different ways you can go about solving a problem like this. I'll tell you the way I prefer, but you do whatever makes you the most comfortable. So we have g to the negative 3 divided by g to the 4. And so what you can do, here's way number 1. You can rewrite this with just flipping your negative exponent. So remember, you only flip the one that has a negative exponent. So just because we have 2 different g terms with different exponents doesn't mean we're going to flip both of them because we have a negative exponent. We only flip the one that has the negative exponent. So to flip g to the negative 3, then we would end up having only a 1 on top, right? Because 1 is actually there. 1 times g to the negative 3, 1 is the coefficient. And then we would have g to the 3 on bottom, but we already have g to the 4 on bottom. So that's going to be there, and now they're being multiplied, okay? Because anytime that you switch a division problem, you're multiplying by the reciprocal. So there's multiplication going on there. And now you can apply your multiplication rules by saying, I know when I multiply 2 things with the same base, you add the exponent. So then this would end up being 1 over g to the 3 plus 4. Should be 1 over g to the 7. Okay, so that's way number 1 of doing it, is just flipping it right off the bat. The way that I prefer is to subtract it first, treat it like a normal division problem, and then flip at the end. And the reason I prefer doing it that way is because it will usually save you a step. So this way worked out so that the negative exponent was on bottom, and we're going to have the same amount of steps. But if you subtract right from the beginning, that will usually save you a step, because sometimes this way will still give you a negative exponent in the end, and then you'll have to flip again at the end. So I wait till the end to flip, so I only have to do it once. But If you prefer to get the negative out of the way in the beginning and maybe end up with a negative later, and that's what you prefer, do it that way. But I'm going to show you the second way now, and it's not much different. So we have g to the -3 divided by g to the 4, which means that we subtract 4. Because in division, when you're dividing two bases with different exponents, you subtract the exponents, right? So g to the -3 minus 4. So this is where some people might get tripped up. When you have a negative minus a number, you're actually making that number more negative. So this is not going to end up being 4 minus 3. There's going to be -3 decreasing it by 4 more. So this would end up being g to the negative, g to the -7. Okay? And so now we have to simplify because we cannot be left with a negative exponent. And this would simplify down to g to the 7 because we're just flipping that g. Okay? So now let's go to a more complicated one. And hopefully it looks a little daunting, but when we work it out, hopefully you'll see that it's not that scary. Okay, so we have 2x² y to that whole value to the exponent of -1, z to the -3 divided by x to the 4, y to the -4, z to the -2. Okay, so I'm going to show you both ways to solve this problem. The first way is going to be us flipping the negatives, and the second way is going to be us doing the subtraction from the beginning. The only hesitation I have to only showing you the second way for this problem is that we will be subtracting negatives. And so a lot of people get scared doing that, get confused doing that. So if you do not like subtracting negatives and the thought of that is kind of nerve-wracking to you, stick with the first way. If you don't mind subtracting negatives and you can keep track of that really well, then the second way can be helpful for you. So I'll show you both ways. So if you want to do it one way, you can just kind of skip ahead of, if you don't want to do it the first way, you can kind of skip a couple of minutes and go to the second way. You'll see it will be a blank screen again with reworking of the problem. Okay, so we said that the first way is that we move our negative terms first and then carry out our subtraction of exponents. So this would look like, because we have 2x² y, all to the -1 here, we are actually going to move that whole monomial. And the reason we can do that is because every single term there, if you're applying your power to a power rule, is going to end up with that exponent of -1. So we'll just save ourselves a step by moving the whole thing instead of applying the -1 first and then moving each thing individually. Okay? So if we move the whole thing first, we're going to end up with, and again, we have z to the -3 on top, x to the +4 on bottom, y to the -4 on bottom, and z to the -2 on bottom. So the things that are on the top that are going to be moving to the bottom are, and you can kind of just like draw a big line when you're doing this, 2x² y and z3. Okay, remember the act of moving it is actually getting rid of that negative exponent. And so, but we're still left with a positive x to the 4, because that we're not moving that, it doesn't have a negative exponent. but now we are moving a y to the 4 on top and a z to the 2 on top, okay? So if we wanted to break these down into their own separate division problems, we would have 1 divided by 2. X is actually being multiplied in the denominator together, so we could have 1 x squared times x to the 4th times y4 over y times z squared over z3. Okay, that got cut off a little bit, but it's z squared over z3 at the end. And so now we just apply our multiplication and division rules when we're dividing monomials. So this 1/2 stays the same. And now we have 1 divided by a multiplication problem. And our multiplication rule says when you multiply 2 powers with the same base, you add the exponents. So that's going to end up being x to the 2 plus 4. Now with our y's, when you divide 2 powers with the same base, it's going to be y to the 4 minus 1. We subtract, okay? And I'm just going to write the z here. Z to the 2 minus z to the 3, because that's another division problem. And so we're just going to be subtracting the exponents there, okay? So I'm going to draw a line here, continue this simplifying in a different color. So we have still 1/2 1 over x to the 6th times y to the 4 minus 1 is 3 times z to the 2 minus 3. So 3 is bigger than 2, so we're still going to end up with a negative exponent there, okay? So now here's where the extra flip comes in that I was talking about. Because we still have 1 negative exponent left over, that's going to end up in the bottom. And when I say bottom, that means denominator of a fraction, right? So we already have some terms in the denominator. We have a 2, and we have an x to the 6th in the denominator. So that z to the negative 1 is going to join it with a power of 1, okay? So our final answer is going to be written as 1. What's left in the numerator is our y to the 3. So it doesn't matter if you write the 1 or not, because everything that doesn't have a coefficient, the coefficient is 1. 1 y to the 3, 2 x to the 6th, z to the negative 1. Sorry, not z to the negative 1, z to the positive 1. Because we flipped it. So whenever you flip it, you can get rid of the negative. So that's 1y cubed divided by 2x to the 6th z. All right, because anything with an exponent of positive 1, usually you don't even include that exponent, okay? So now I'm going to erase this and start over and work the problem out with subtracting first and flipping the negatives at the end. Okay, so now we're going to work the problem out by doing the subtraction first. And what that's going to look like is we're going to apply that negative 1 exponent to everything inside the parentheses. And so that would just be our normal multiplication rule, where if you're multiplying, or when you're taking a power to a power, you multiply the exponent. So this is going to look like 2 to the 1 times negative 1, x to the 2 times negative 1, and y. to the 1 times negative 1. Because if it doesn't have a specified exponent, the exponent's 1. Okay, so simplified, this monomial, or this expression inside of those parentheses, is going to become 2 to the negative 1, x to the negative 2, y to the negative 1. And now we can write it as normal after we applied that exponent. Okay, with our x to the 4 on bottom, y to the negative 4 on bottom, and z to the negative 2. Okay, and so now what we can do is actually break these up into their own division problems. So we have, and I'm going to do this in a different color to the left here. So now we have 2 to the negative 1 being just divided by 1, right? And now we have the x terms. Here are x to the negative 2 over x to the 4. The y terms, y to the negative 1 over y to the negative 4. And the z terms, z to the negative 3 divided by z to the negative 2. Okay, so now that we have these 4 separate division problems, now we can look at subtracting their exponents. But you have to be careful because some of these have negative exponents in the denominator. So that means that you're actually subtracting a negative exponent. So if be careful, use parentheses here whenever you're subtracting negatives, because when you're subtracting a negative, that's going to become positive. So we end up with 2 to the negative 1, x to the negative 2 minus 4, y to the negative 1 minus minus negative 4, and then z to the negative 3 minus a negative 2. Okay, so in a different color, after we simplify the exponents or reduce the exponents, we're going to end up with x negative 2 decreased by 4. So we're making a negative 2 more negative. So it's going to be a negative 6. Now we have a y negative 1 minus a negative 4, which actually means plus 4. So we have a negative 1 being increased by 4, or a 4 decreased by 1 would be positive 3. And a z, we have a negative 3 minus a negative 2, which means we're actually adding 2. So we are increasing a negative 3 by 2, which would mean we end up with z to the negative 1. Okay? So now we are left with our almost simplified form, but we can't have negative exponents. So to simplify the rest of this, we have to flip the terms with negative exponents. The ones with positive exponents can stay on top or be the numerator. The ones with negative exponents will become our denominator. So what this will look like, I'm going to write it over here because I have a little bit more room. The only thing that has a positive exponent here is our y to the 3. So everything else is going to end up in this denominator. So that's going to be 2 to the 1, or just 2. And again, we're getting rid of the negative by switching the side of the fraction from the numerator to the denominator, x to the 6, and z to the 1, or the things you have here with exponents of 1, you also don't have to write the exponents, because anytime we have a number or a variable with an exponent of 1, it's usually not written. So you can write it, it's correct, but just know, like, if you're filling out multiple choice, there might not be a 1 there. So just be aware of that when you're selecting your answers. So those are the two ways to solve negative exponent problems. You can either flip before and carry out your subtraction and then flip again if you have to, or you can carry out your subtraction from the beginning, being very conscious of subtracting negatives and then flip at the end. So I hope that video helped you understand negative exponents more. And as always, reach out if you need any help with the 7.2 Part 2 independent practice. Office hours are from 9 to 11:30 and from 1 to 2 every day. And Mr. Whirling is very eager to help someone. So if you need any help at all, please go. So that's it. Thanks.